Hi everybody. In this lesson we want to look at how we multiply some radical expressions together. So let's get started. If we have the square root of 4 times the square root of 9, if you think of those in terms of a fractional exponent, this would be 4 to the 1/2 times 9 to the 1/2. And you remember by our rules of exponents, we could put that as 4 times 9, that quantity, to the 1/2, which is of course just the square root of 4 times 9. So what we're illustrating here is if you have a square root times another square root, you can put both of those radicands under a single square root, and that'll give me the square root of 36 in this case, which is 6. And you'll notice that the square root of 4 is 2 over on this side, and the square root of 9 is 3, and 2 times 3 does equal the square root of 36, or 6. All right, so that's true of any radical, as long as your indexes are the same. The nth root of x times the nth root of y will be the nth root of x times y. So you can put both of those under the same radical. So the cube root of 2 times the cube root of 5 would just be the cube root of 2 times 5, and you wouldn't even have to write 2 times 5 there. You could just say that's the cube root of 10. Okay? Or if I had the fourth root of 8a times the fourth root of 2a to the 7th, I could write that as the fourth root of 16 a to the 8th. In this case, I can go ahead and simplify that. I could even break it up again. I could write this as the fourth root of 16 times the fourth root of a to the 8th. The fourth root of 16 is 2, since 2 times 2 times 2 times 2, multiplying 2 by itself 4 times, gives me 16. And the fourth root of a to the 8th, well, that's a squared, again, because a squared times itself 4 times is a to the 8th. Or if you wanted to, you could think of this as a fractional exponent. Remember, the power is the numerator and the root is the denominator. And a to the 8/4, the 8/4 does reduce to 2, so I get a squared. All right, let's do one more here. The square root of x to the 6 times the square root of or x over 6 times the square root of 12 over y, that would be the square root of 12x in the numerator over 6y. And then you could go ahead and simplify the 6 and the 12 there, since they're inside the radical together. And so this would just be the square root of 2x over y. Okay? In a later lesson, we'll see how we might simplify that further, because usually we don't leave radicals under the in the denominator like that, or a fraction inside. But for right now, we'll leave it like that. All right, the square root of x minus 4 times the square root of x plus 4. Again, I can just put those under the same radical. X minus 4 times x plus 4. That would be the square root of x squared minus 16. All right, now you see a big danger right here, because the temptation for students who are just learning about radicals is to want to take the square root of that x squared and the square root of 16 and say that that is just x minus 4. Well, that's the big danger. That does not equal x minus 4, since x minus 4 squared does not equal x squared minus 16. So you can't take the square root of terms like that, and it might help you to avoid that confusion if you remember, if I had the square root of x squared times 16, you could break that up as the square root of x squared times the square root of 16. That's okay. But if I had the square root of x squared minus 16, that does not equal the square root of x squared minus the square root of 16. Okay, so if it's a plus or a minus, you can't break it into separate square roots, but if it's times, then you can. Okay?